Welcome, everyone. Welcome, people of presumably Earth or the simulation. We don't know. We will probably never know. Today, we're going to continue going through tutorials. We can actually go straight to there. Bam, here's the tutorial. Or more like finishing line of the Rockies tutorial for Godot. I figured, you know what, I'm gonna take a peek at that too, recreate the project quickly. So I did that, now I just need to finish the audio part and export, and that'll be it. And then we can look at something else. I don't know at what yet. We'll see what we feel like. Probably, we might actually use also his tutorial for the GD script and just run through that, see if there's something worth learning there. Okay, so far the current state is that we have something that looks like this, the standard thing from the tutorial. I didn't bother with text because there's nothing inventive there. All we can do here is move around. We can jump, collect the coins, and that's pretty much it. And when we die, we get reset. And we have a moving platform. And come on. Yeah, I think for tomorrow's stream, we'll take a look at making jumping and stuff better. And bam, and you fall and you die. So, you know, the same stuff as in the tutorial. Let's just run through the rest of the tutorial and get it done. Let me make sure the audio is on. Desktop audio. There we go. Now it should work.
One of the things that often get overlooked when making a game is audio, but music and sound effects are a huge part of building the mood of your game. This is of course a beginner's tutorial, but let's at least get our feet wet, or should I say our ears wet? Nope, I shouldn't. Let's at least add a music track and a pickup sound for our coins. Now in the assets, I've included a music track as well as a few sounds. And to play these, we need a new type of node, the audio stream player. So let's add a new node, search for audio stream player 2D.
Okay, that's gonna be real simple. I think I'm gonna skip the music.
Name this to music. Then we can take this is not going to loop. To change that, let's double click it. This is going to open up our audio importer. Here we can preview our music track. Groovy. Anyways, we can loop. So let's enable loop here and hit re-import. Now by default, all sounds are played fairly loud, and since this is background music, we probably want to turn it down a bit. We can do this by adjusting the volume on each individual audio stream player, or we can use the audio tab. Let's add two, one for our music, as well as one for sound effects. And then we can simply route our music here into our music bus. So now we can control the volume of our music using this slider. I'm just going to set it to -12. And we have music. Unfortunately, it's going to restart whenever our scene is reloaded. A quick fix for this is to take our music node and make it into a scene. So I'll click and drag it into our scenes folder, hit save, and then we can add this scene as an auto load. Auto loads are global scenes and scripts that we want to persist throughout our entire game, no matter which scene is currently loaded. So let's remove music here from our game scene and instead go to Project, Project Settings, Auto Load. We'll click the little folder here and navigate to our music scene and hit Add. We've now registered our music scene as an auto load, which means that if we now play, even though our music scene isn't in our game, it automatically loads and starts playing our track. And even better, it doesn't reset when our game restarts. Now to add a pickup sound, we go to our coin and add an audio stream player. Let's rename this to pickup sound, drag in our coin sound, and set the bus here to sound effects. And now we can actually play this sound through script. But since we're removing the coin...
Okay, let's do the coin because I think there was some more fun stuff there. So... I see switching the wrong thing. Okay, so let's go to the coin. And what do you add? Just the audio stream player. Yeah. Audio stream player 2D. There we go. What do you call it? Pickup sound. Alrighty.
Coin immediately by calling the queue-free function, the sound won't actually get a chance to play. We can of course fix this by adding code that waits until the sound has finished playing, but then we might get weird functionality where we try to pick up the coin multiple times while it's playing and it will still be visible until the sound is finished. So let me show you a really cool trick to get around tricky timing things like this without writing any code.
Really? Oh, that would be fun. Coin. There we go. What does it sound like? Very standard.
Is using an animation player. So let's add an animation player. And here we'll create a new...
Okay, That sounds cool. Animation player.
Pick up animation. And the first thing that we want.
Okay. New animation. Pick up. If animations are as easy to create as I think they are, like, you know, like the other stuff, that would be great.
To do when we pick up the coin is to hide the coin sprite. So I'll go into the animated sprite 2D, and this will change the window. So I'll go back to animation here. And now under visibility, I get to keyframe the visible property. Now when working with animations that don't need to play until later in the game, it's nice to be able to go back to the default values after animating. By default here, our coin should be visible. Now this is pretty cool. If I just create a keyframe here for the default value, Godot is going to ask to create a reset track. If we say yes to this, Godot is automatically going to create another animation track called reset that will simply reset this value to its default state. So now in our pickup animation, we can keyframe it to whatever we want. In our case, when we pick up the coin, we want it not to be visible. So I'll disable that, keyframe it, and then
That's cool. All right, so let's click the sprite, get back to animation. We're at 0. We're gonna do the visibility. Create a reset track. Yes, please. And we've got it. Awesome. So we're gonna make it not visible when the animation starts. I click that. It's empty.
if we want to go back to our default values, we simply go to our reset track, and there it is. It goes back to default. So let's go to our pickup. Let's also modify our collision shape. We don't want to be able to collide with it while it's playing the sound. So let's simply go ahead and add a default key here for the disabled property. Hit create. And now we can set disable to true and add a new key.
Okay, so this is basically for various elements. It's gonna add it to the reset track. So I'm gonna go here, disable this. It's not disabled right now. Create new track. Purple disabled and insert key. Yeah, hold shift when clicking the key to skip this dialog. All right. So now we're gonna make it disabled in the beginning. And we'll have, yeah, the same reset track there. Okay, cool.
We can also go into our pickup sound here, and let's add a default key for the playing property. Let's hit create. And now since the sound plays pretty quickly, I can't actually reach the key in time. So we can go down here instead. I'm just going to scale this up a bit. Go down here to the value, the keyframe here, and change it to on. So we can.
All right. So pickup sound, playing. Yep. And then we're gonna do, yeah, exactly that. Value will be on. All right.
Actually modify the keyframes here as well. So now we have our pickup animation, and if we go to reset, we can see that everything goes back to default. So that's just a nice way of working with animation. So now we play the sound, disable the collider, and hide the sprite. After 1 second though, we can go ahead and remove the coin from our scene. So all of these keyframes here
so
are on second 1. Let's put them over to right at the beginning of our animation at second 0. And then after 1 second here, we want to remove our coin. And this is a really cool part about the animation system, is that we can actually add another track here, a call method track, that is used to calling functions. So on our coin, we want to call a function, and I'll right click right where we want to do.
Okay. That's fun. So let's switch. Oof. How did you add the track? How the hell did he add the track?
And this is a really cool part about the animation system, is that we can actually add another track here, a call method track.
Huh. And I'm gonna get the whole coin thing.
That is used to calling functions. So on our coin, we want to call a function, and I'll right click right where we want to do that.
Insert key. Free. Node or object, doesn't matter. Probably from node. Yeah,
insert key, and the function that we want to call is the queue_free method, which is right here. And so now, after 1 second, it's going to call the queue_free method on our coin without us writing any code. And voila, all the things we could have done through code are all inside this animation.
Cool.
And again, to get back, we simply choose reset. Now all that is left is playing the animation through script. So in our script, we'll get a reference to our animation player. And then instead of directly calling queue_free, we'll go animation player.play pickup. And if we play now, we can hear our music, and we can hear our pickup sound when we run into the coins. Awesome. Export!
All right, I see. Yeah, kind of don't like it, but oh well. I don't like just disabling some random stuff. Okay, so inside our coin, script. Instead of Q3, we'll be doing animation thingy. Animation player dot play, and that was the pickup. Right? Yeah, that should be it. Hopefully. Let's see. Okay. I can live with that. Wow, I really can't play it. And there's a bunch more sounds to add and whatnot. Yep. Cool. So what's next?
Finally, we are ready to export. Really incredible that you made it this far. You can feel very proud. So let's get our game out of Godot so we can share it with others. Godot can of course export to many different platforms, but I'm on a Windows computer here, so let's go ahead and make a quick Windows build. The first time we are exporting our game, we need to download the export templates. These are a little large, so to keep Godot lightweight, they aren't included by default. To install them, we go to Editor, Manage Export Templates, and hit Download and Install. And the export templates are installed and ready to be used, so we'll close.
Okay. Export templates. All right. I'm missing. Download them. Sure. One gig. Okay. It'll be a wait. Okay. Great. What's next?
Go to Project and Export. In this window, we'll add a build platform, so let's go Add, Windows Desktop. We'll enable Embed PCK, which will export it into a single file. Then we scroll down. As for the product name here, I'm going to type in Princess Dragon Slayer, and we can hit Export Project. I'm simply going to put this on my desktop, uncheck Export with Debug, and hit Save. This warning is not a problem. We'll hit OK. And now...
Okay. Project, Export, and Windows Desktop. And we're gonna do sure. Wow, this is a little bit too large. Let's just make it look like this. Okay, so PCK to just have pack files. Sure. Are there any? Oh, to ARM as well. Wow. Okay, that's fun. Okay, setting the icon and a bunch of other stuff. Boring game. Yeah, did he do anything else? No.
On the desktop, we have this tab, uncheck Export with Dragon Slayer, and we can hit Export Project. I'm simply going to put this on my desktop, uncheck Export with Debug, and hit Save. This warning is not a problem.
All right, let's just plop it up. Folder exports. There we go. Boring game. No debug. Now let's see the size. I'm curious about the size. Not start RC edit executable configure.
We'll hit OK. And now on the desktop, we have this first game.exe. We can open that up, and voila.
Oh, it's just random error that we don't have to worry about. So we can go here, exports, and we have this, and that's 85 megs. Okay, I can live with that. It already started here. I wonder if it loaded also resources that shouldn't be there. Yeah, I mean, that looks exactly as it was supposed to. Awesome. Awesome, awesome, awesome.
We made a game.
Alright, so
And
that's
it.
basically it.
Congratulations on making your first dish, or game in Godot. If you don't understand everything or are unsure about where to go from here, don't worry. That's totally normal. It takes a little while to become familiar enough with the tools to feel really free with them. Never hesitate.
So there'll be ad for Zenva after that. Sure. So let's just continue with his stuff and take a peek at the how to GD script in 1 hour.
A
We're gonna
high-level,
make it into
object-oriented, imperative.
half an hour, unless we'll be running around. But what do we have here? We have in chapters hello world, syntax, modifying nodes, input variables, if statements, comments, variables, functions, random numbers, documentation, arrays, loops, dictionaries, enums, match, modifying nodes, 2, signals, get set, nice classes, inner classes, inheritance, composition. Okay, great. Call down, signal up, and style. And that's it. Okay, that might be a decent, short little introduction to the language. So maybe we're just gonna go through that because, to be honest, I could really use that. Because so far, the tutorials that we went through, they were like a little bit here, a little bit there. We searched for a few things ourselves. But this language is kind of weird at points. I guess just because of how tightly compatible it is with, it's made for Godot. So it has some weird little things that you wouldn't normally see in a normal language, just because this one is specifically for a game. So yeah, let's take a peek through that.
GD script, a high-level, object-oriented, imperative, and gradually typed programming language with syntax a lot like Python built specifically for Godot. I know that sounds like a lot, but today we're going to learn it. While it's of course impossible to cover everything an entire programming language has to offer in just one video, we'll certainly try. In fact, we'll cover everything from variables and conditionals to getting input, inheritance, dictionaries, signals, and the list goes on. And who knows, perhaps we'll even figure out what GD stands for. Gandalf script? Green Day script? Gadolinium? We might never know. We'll start with the things that are considered to be most important for beginners, and then move on to more abstract programming concepts as we progress. It's not as much a follow along as it is an overview. So if you're a beginner, lean back and know that you don't have to understand everything. Hello world. So here we are in an empty Godot project. It's really spacious in here. As it is custom, let's begin by making a script and adding some code to print a message. To do that, we need a test scene, so let's go and hit the plus. I'll add in a node, rename it to main, and let's save this as a scene. So I'll hit Ctrl S, hit save. Let's add a script by pressing this scroll. We'll use the default template, and the name of the script should be main as well with a non-capital M. This creates a script with 2 functions. We'll start by focusing on the top one named ready. Think of this as the start of our game. As it says here, this function is called when the node enters the scene tree for the first time, which happens right when we play our game. So we can put code in here that we want to happen immediately. I'll get rid of the other function for now. You can zoom in by holding down Control while scrolling. Now right now the only thing in our ready function is the pass keyword. Pass basically means do nothing, and it will appear in functions we haven't filled out yet. So let's replace it with some code that prints our message. We'll write print, and inside the parentheses we'll put our message in quotation marks, hello world. We can then run the game by pressing this button here or hitting F5. It's going to ask us which scene we're going to run. We'll hit select current. And while our game isn't very exciting yet, we can now see that the console prints our message. The output window here, or the console, is where it will display prints, and it's also where we check for errors.
Okay.
Now to stop our game from running, we press the stop button here or press F8.
But there's no
syntax.
3 times
Now
button.
this might have worked for you
speed.
and it might not. That's because there are a few things to be aware of when writing GD script. The first is that statements like print here terminate with a new line. There's no need to add a semicolon at the end like in many C-based languages. And GD script, similar to a language like Python, uses indentation to determine the structure of your code. This means that you use tabs to tell GD script where your code belongs. In our example here, I'm using a tab to tell Godot that our print line belongs to the ready function. If I delete this tab, I get an error. Also, GD script is case sensitive. So if I write print with a capital P, I will also get an error. So just a couple of things to look out for there. Now printing to the console is cool. Or I mean, maybe not as cool as backflips, but well, I can't teach you to do those. But I can teach you how to display text in the game window instead. To do that, we'll need to modify a node through script. Modifying nodes 1.0. First, we need a node to modify. Let's use a label. So I'll add a new node, choose label. I'll zoom in, center it on the screen. Make some more room. Let's add a default text. This is a label. I'll center it and overwrite the font size. Now, to edit the text of this label through script, we need 2 things. We need a reference to the label, and we need to access the property in the label that we want to change. In this case, the text. If we hover over text, we can see the name of the property through script, which is text with a non-capital T. So in our main script, we'll first get a reference, and we can actually do this by simply taking the label and dragging it into our ready function. Then we can access the property by going dot, and we'll type in text and set it equal to hello world. And now when we play, our label changes to hello world. And we can use this exact method to change other things as well, such as the color of the text. In fact, there's a property called modulate, which allows us to tint sprites and UI elements. In the inspector, you can find it all the way down here under visibility. Let's change it to green. So again, we'll click and drag to create a reference to the label, write dot modulate, and set it equal to color dot. Here we have a bunch of different colors. We'll choose green. And voila, our label is now green. So this is how we can make changes to nodes when our game is running. But right now, not much is happening during our game. So let's see how we can use input to make our game respond to our actions.
I think what he should also mention here is that, sure, we drag that label here, but if you rename this code won't update. I think that's something worth mentioning.
Input. Let's say we want to turn this label red when we press the spacebar. To do this, we first need to set up an input action. We'll go Project, Project Settings, Input Map. Here we can add actions. Actions allow us to bind keys to something that we want to happen. Common actions would be shoot, jump, or so on. In our case, we wanted to change the color. I'll just go ahead and call it My Action, so we can use it later for other things. Now let's hit Add, and here's our action. Let's bind a key to it by pressing plus. It's now listening for input. I'm going to press the spacebar and hit OK. And now our spacebar is bound to My Action. Then in our script, we need to create an input function. We'll write func for function underscore input, and let's hit enter to autocomplete. Now, just like ready, this is one of the built-in functions of Godot, but instead of being called at the start of the game, it runs every time the game receives any input, such as when we press a button. Event is what we call the information about what triggered the function. Was it a movement of the mouse or the press of a key? We need to check if the event that triggered the input was our action being pressed. So we'll write if event.isActionPressed. As you can see, our action shows up here, my action. Then we'll put in a colon, and if we pressed my action, well, then we'll change the color. So we'll drag in the label, write .modulate, and set it equal to color.red. And we can just as easily check if the action was released. We'll go if event.isActionReleased this time, my action. Well, then we'll take the exact same line and change it back to green. So now when we play and I press the spacebar, it turns red, and when I release it, it turns back to green. That's right, we made a party. Hey, disco.
Yeah, I like that he also went straight into the underscore input method. Just overriding that. Unlike, in your update doing something. So I like that this is being shown, not something else.
Go party. Now this is just one out of many ways to handle input in Godot, but since we're focusing on the GDScript language, I'm not going to go further into it here. I'll make sure to provide a link to where you can learn more about input if you're interested. Variables 1.0. Variables are essentially containers that hold information. In the case of a player character, we could use variables for information like the player's name, health, damage, and perhaps if the player is alive or not. Let's make a health variable. At the top here, I'll write var for variable, the name of our variable, and then we'll set it equal to a default value. Now we can print this variable inside of our ready function. We'll write print health. And if we play, you can see that it now prints 100. Now we can easily change our variable. So before printing, let's assign a new number. Health equals 40. We can also assign a calculation. So health equals 20 plus 30. We'll set our health to 50. We can also add health plus equals, and then 20 will add 20.
Hello, Arton Alexis. Yeah, hello world in Godot, yep. Why not? Exactly. As long as it prints, right? You can call it hello world. How are we doing?
To our health, and subtract health minus equals. To multiply, we do times equals, and to divide, we do slash equals. So if we run this now, it will do all of these calculations from top to bottom, and then print out the result, which turns.
Question is, does it keep the... I guess it doesn't turn health into a float in here, right? Let's actually test that. That would be very good to know. I presume it being probably mostly conservative. I would expect it to just, not magically convert stuff. Come on, close the thing. Let's open up a new Godot instance. And create a new project. Oh, geez. Gonna go into here. Projects, new folder. GDs, where? Brockies 2. That's what we're gonna call it. Oh. I see. It doesn't if it is declared as an int. Okay. And you can use browser. Oh, as in the browser version of Godot. Yep, I have it installed here, so no biggie. I just want to see for myself. So sure, this is good enough. So yeah, let's use ready. And let's do this. So if I'm gonna make a variable, A is 12 and var B is 7. And we'll do var C is A divided by B. So I defined them. They initially have an integer value, but I didn't specify that it has to be integer because as far as I know, in GDScript, just like in Python, you can change the type as you go. Oh, way faster than making nodes and stuff. Oh, you mean there's a browser like for running Godot script in the browser? That's interesting. Unfortunately, you can't paste in the link. So probably by adding some spaces, it could work if you wish to share that. Print string C. Sure, whatever. Let's add those things. I'm mixing nim and GDScript. So we got 1. Okay. All right. What if I'll define that as a result I want to have a float? Probably still be the same. Yeah. Only if I'm gonna make this as a float, only then it's actually gonna divide properly. Yep, exactly. All right, I see it. And can I make A into that? No, okay. So, because I'm trying to redefine it. This doesn't complain. So initially I presume is integer. So print string A. And we're gonna do A by 7. Yes, so first one is just 1, and the other one is 1.7. So initially it holds an integer, therefore dividing like that doesn't change it. While here, we redefine it into actually holding an integer, which is awesome. Okay, cool. So Artyom like says, yeah, GDScript emulator. gdscript-online.github.io. Okay. All right. Yep. But the thing is that if I will do it as float or as this, this will make it assume this type. Therefore, I wouldn't be able to do it. So if I would define it with this, this should fail. Theoretically, it's supposed to fail. So let's run it. See, it tried to redefine it, but no, it got turned into a integer anyway, even though this was a float. So that's the difference. If you want to specify the type and not have it automatically assume some other one, you can just lock it in this way. And Anxiety says hello on YouTube. Hello to you too. How are you doing? So let's check out that website. I am curious how GDScript Online works. GDScript dash online dot GitHub.io. Huh. Really? Come on, you can't increase the font like that? No. What the heck? You can't even right click. Oh no, it's one of those apps that don't let you change anything. And because this is some weird Arc browser, can we do something about it? Come on. I want to zoom in. Oh, it tries to zoom in the corner, but the website Oh, this is written in Godot, probably. That's why. Something tells me this whole thing is written in Godot. Therefore, we can't scale it. And that's why F12 won't work either. Huh. Middle bar to the right. Yep, I agree with what you're saying. Drag the middle bar to the right. Yeah, we can resize this. But no, I just wanted to resize the size of the font. So that it's more visible on a stream. Not everyone watches, on 2K screen or something. But we have it set up here for now. But it's cool to know that you know there's a website like that where we can run it, and we're gonna get it right here. Awesome. Huh. Cool tool. Getting back to... Okay, so we know how dividing works. And let's see what
820. Let's look at an example where our player takes some damage and we want to subtract the damage from our health. Let's try decreasing our health variable whenever we press the action we made earlier. So in the input function, we'll check if the action was pressed. And then if statements. If statements or conditionals. If statements are the glue that holds all of our logic together. We've actually already used if statements to check if our action was pressed, but they can do so much more. Yet they are really simple. An if statement is just a condition that needs to be met in order for the code inside to be run. Let's add an if statement here to check if our health reaches 0. So I'll make some room, write if health is less than or equal to 0. Well, then we'll set our health to 0 and we'll print that we died. And now when our health gets to 0, it prints you died. Now here we're using less than and equal to compare our health to the value 0. But there are many more comparisons we can make. Here are all the comparisons we use, such as is equal to, is not equal to, and so on.
Okay, I'll just them, unfortunately. I can see it no problem, but you know, some people might watch on a phone, some people might watch on a 1080p screen, and it's just gonna be not fun. And that's the part about streaming. I have to have my Godot with like 125% scale, so it's nice and visible.
Define what happens when the condition is true. We can also choose what happens when it's false. We do this using the else keyword. Let's add an else to print that we are still alive if our health hasn't reached.
Okay, else.
And if neither of these two are true, we'll go to else and say that we are healthy and have so much in common. We both tend to spend a lot of time with the ifs and the what ifs. So if you get frustrated along the way, remember that so was Play-Doh. Anyway, that's it for if statements. Comments. We use comments to help explain and remember the what and the why of our code. Adding a comment is simple and can be done above or after a line. So if we have some code, we can make a comment above the line. And this is a comment about the code that follows, or we can make one right after. And this is a comment about this line only. We can also use comments to temporarily remove parts of our code from being executed. Here we simply put a hashtag in front of the code. And it's good practice to omit the space here to indicate that what follows is code. We can also select multiple lines of code, right-click, and toggle comment. Just remember that you can't have a completely empty function. We need to add the pass keyword to avoid an error. Variables 2.0. When creating or declaring a variable, we need to think about where we do so. If we declare a variable inside of an if statement, for example, we can only use that variable inside of the if statement. This is called scope, and it's something that beginners often make mistakes with. If we want to use a variable in many different places in our script, we make sure to put it at the top, outside of any functions.
At least I have something to worry about.
Variable. This can be accessed anywhere in your script. If you were to declare it inside of a function, you would only be able to use it in that function. So this is a variable we can only use in ready. Now, a really cool thing about variables in GDScript is that you can declare them without thinking about what type of data is inside them. Here's a variable that is either true or false, and here's a variable that stores a number. As you can see, they're created in the exact same way. In fact, we can even change the type of data that they hold just by reassigning them. So we can actually set our coolness to true, and this runs completely fine. That being said, we still need to be aware of what type of data we're working with, because some parts of our game will expect a specific type of data, and we will get an error if we try to use another type without converting. Now, in GDScript, we have the 4 classic data types: Boolean, or bool, for true and false, integer, or int, for whole numbers, float for numbers with decimals, and string for text. Converting from one type to another is called casting. For example, we can cast an integer into a string. So if we have a number that is equal to 42, we have some text, which is a string. But then we can add the number to this text, while we convert it into a string by writing str for string, and then the variable inside of the parentheses. And if we print this, it works fine. We can do a similar thing to, say, convert a float into an integer. So if we have a variable called pi that is equal to 3.14, then we can convert this into an integer by...
I'm not sure if I would call it casting, really. This is more like just, you know, call a function that formats it.
Going int pi, and let's print this. And it prints 3, a whole number. Note, however, that this automatically truncates the number. It does not round. It simply gets rid of the decimals. So 3.9 also results in 3. Some other data structures that are really common in GDScript are vector 2 and 3. Vector 2 stores 2 floats, x and y, and vector 3 stores 3 floats, x, y, and z. These are most commonly used for positions. So I can create a variable called position with some coordinates. I can then modify one of the components. So position.x plus equals 2 adds 2 to the x component, and then we can print the whole thing. And this gives a vector 3 of 5 minus 10, 5. Now, by default, GDScript is what we call dynamically typed. This means that we don't define what type of data a variable can hold when we declare it, which we've been using so far. This makes it fast to create variables and flexible because we can reassign data of another type at will. However, it is also more prone to error and less performant than static typing. Luckily, GDScript allows us to statically type any variables we want. We can pick and choose totally based on preference. To statically type a variable, we simply add the type when declaring it. So here, if we have a damage variable, we can specify the type and then set the value. So now this variable will always stay an integer. We can even have Godot automatically determine the data type by simply writing colon equals and then the default value. This is called inferred typing, and the result is exactly the same. The type is still static. Godot simply recognizes that 15 is a whole number and sets the variable to a type of int. This also means that the variable cannot change to another type. If we try to set it to a string, we get an error. Now, adding export in front of a variable will allow us to set it using the inspector. The value that we set in the script will just be a default value. So if we save this and select our node, we can set a value in the inspector. If we print our damage, we can see that this updates in our game. And we can always press the circular arrow to revert back to the default. Now, sometimes you want to define a variable that cannot change. For this, we
Shu says hello on YouTube. Hello to you too. How are you doing?
use constants. So I'll write const for constant. We'll call it gravity. As you can see, it's standard practice to name constants with capital letters. And we'll set it equal to negative 9. To
be honest, I hate naming constants with capital letters. What's so special about them? It doesn't change. Yeah, like most variables you define, you just store the value in them and they don't change. So I just don't like that practice of making capitals.
81. Now we can use this like any other variable, but we cannot change it. If we try to do that, it throws an error. And that's it for variables. Great job. Functions. Functions are the bread and butter of programming. They allow you to bundle up your code in small reusable packages. So far, we've been using some of Godot's built-in functions like ready and input. Notice how these are prefixed with an underscore. This is to show that they are not activated or called by us, but by the engine itself. But we can actually make our own functions and use them to do really cool things.
Oh, so that's another thing. That explains. Okay, when it has underscore, is just simply because it says, okay, this is from the engine. Therefore, other tutorials that define their own ones with underscore in the beginning, why do you do that? Just to make it more difficult to write it for yourself?
Common functions to making games are things like jump, die, shoot, and respawn. And making a function is actually really easy. Let's make a function for jumping. So we'll write func, then the name of our function, open and close parentheses, and a colon. Then in here we'll put all of our code for jumping. So we could add an upwards force, play a funny sound, and a jump animation. For now we'll just print jump. But nothing is currently triggering or calling our function. Let's call it whenever we press the action we made earlier. So func underscore input event, and if our action was pressed, then we call our jump function by writing jump followed by open and close parentheses. And now when I press space, it displays jump. And at this point, I encourage you to add the sound effect yourself. Boing, boing. A lot of fun to be had here. Actually use functions for much more than this. They can have inputs and outputs. Let me explain. I like to think of functions as machines. Take for example this coffee maker. Just like the name implies, it performs a function to make coffee. Delicious coffee. Add, and then inside of our parentheses, we add the parent result variable. We'll set that equal to num1 plus num2. And for now, let's just print the result. Then in ready, let's try calling this function.
Skipping a bunch of stuff here.
We'll give it the first number, 3, and the second one is
really
2, 8.
basic.
And let's actually call it again. So let's do a harder one. Let's add 245 with 111. The numbers we want to add together. But the function actually doesn't return the result. It just prints it. This means that we can't actually access the result where we're calling the function up here in ready. To return the result, we replace print with return. So we'll do return result. And now up here, we can store the result in a variable, set it equal to add, and we'll add together 3 and 5. And we can print that, and the result is 8. And because we have access to it up here, we can do more things. Like add more numbers to it. So we can say result equal to add, and pass in the result from before, and add 10,
value
and then
without
print.
specifying.
And there you go, we now get 18, because 3 plus 5 plus 10 is 18. Really cool. And just like when declaring variables, we can also statically type parameters and return types to make it clear that the function is made to work with numbers. So after num1, we'll specify that this is an integer. We'll do the same thing with num2. And here we can set the return type using an arrow, and this is also an integer. So now this function will only work with numbers. 3, 4, 6, 8, 2, 1, 1.5. Random numbers. Getting random numbers is very easy. The function randf gives a random number between 0 and 1. It's great for assigning probabilities to your code. Say we're deciding what loot to give the player, and we want to make some loot more rare than other. Well, in this case, we could create a roll variable and set it equal to randf. Then we could
Oh, you don't need to create a random number generator like the other tutorial? Huh.
check if the roll is less than or equal to 0.8, which means there's an
That's convenient.
80% chance that we print you found a common item. And if not, well then there's a 20% chance that you found a rare item. And if we play this, most of the time it's going to display that we found a common item. But if we keep playing, eventually, there's a 20% chance, so at some point, we'll eventually find a rare item. That was crazy. We can also use rand f range and rand I range to get a random float or integer between a minimum and maximum value. Say to assign a random height to a character. So var character height equals rand I range for a random integer between 140 and it's due to 10. And we'll print that your character is, then we'll insert the height, remember to convert to a string, centimeters tall. And we'll roll the character, and apparently I am a giant. Basketball, here I come. Documentation. GDScript is actually pretty well documented. And one of the really cool things about it is that the documentation is linked with the editor. If you hold down Control and click on something we would like to know more about, such as the rand I range function, it opens up the documentation right here in the editor. This is a really quick and easy way to check if you're using a function correctly. It also works for classes, which we'll learn about later. Arrays. Sometimes you want a variable that can hold more than one thing. In fact, sometimes you might want to store.
What would be the purpose of specifying the random number generator then? Like manually? I guess you could pass it custom seed, and that's why? Huh. That's an interesting thing to check too, because can I just make print and just convert it to string rand? Yeah, I have them all in range of 0 to 1.5, right? This should work no problem. Bam. Will it be the same number next time I run it? No, it's different. Okay, so the seed seems to be random. Okay. For RNG is random number generator. Wait, new random number. No. Dot. Okay, we've got new. And that new is just that. It doesn't have definition here. Too bad there's no. Okay, random number generator provides methods. Class will generate pseudo blah blah blah. Then like this implementation of this to generate a random number within a given range. So it shows that we need to do that. Okay. And we can specify the seed. Okay. Set seed and get seed. Okay. That's useful. Then we can have basically a bunch of seeds for various stuff. So that makes sense. The current state, saves and restore. Okay, so that's good for, all right. So I see this is useful when you're making like save files. Let's say your game needs to work in a way that, let's say it's something like, you're making a game where from time to time there are random events, right? And, you know, throughout the game, as the game goes, you use that specific random number generator that is here to get some random values to decide, you know, should something bad happen, like a raid to your colony, or maybe something good happens, like, I don't know, a random person comes and brings you some good stuff, whatever. Some event needs to happen. And what some people could do is do like, oh gosh, this bad thing happened. Maybe I'm gonna reload the save from then and just, why not? Reload and maybe the thing isn't gonna happen. So what you could do here in your save files, you actually save what is the seed, which is like the specific random pattern that's gonna happen, and the current state, because every time you read from the seed, the next random, you know, the next number is different. So this way you could get a state too. Save those two things, and suddenly you can just reload them, and the next random number will be exactly the same as if it was, you know, the previous time you played. So that's when we would use the specifically this. While if we're just doing something, it doesn't matter if it's random or not. You know, if it's always the same sequence, we just use it with normal randomness. Okay. Cool. And what was documentation?
Documentation. GDScript is actually pretty well documented. And one of the really cool things about it is that the documentation is linked with the editor. If you hold down Control and click on something we would like to know more about, such as the range function, it opens up the documentation right here in the editor. This is a really quick and easy way to check if you're using a function correctly. It also works for classes, which we'll learn about later. Arrays. Sometimes you want a variable that can hold more than one thing. In fact, sometimes you might want to store a whole list of elements. For this, we use arrays. Defining an array is very easy. Let's make one to hold items in an inventory. So we'll create a normal variable and set it equal to open and close square brackets. This creates an empty array. We can then add elements inside the square brackets. I'll add a potion string, the number 3, and the number 6. Notice how, unlike many other languages, GDScript has no problem mixing data types within an array. But if you want to constrain an array to a specific type, we can of course statically type it. So here we simply add the type. This is an array, and the elements inside it are going to be strings. So that's the syntax for that. And now we get an error because 3 is not a string, so we'll replace this with feather. And 6 is also not a string. We'll replace that with stolen harp. Now, the way that we access elements in an array is by using an index. When you add an element to an array, it is automatically assigned a number based on its position in the array. In this case, the first element, potion, has an index of 0, feather has an index of 1, and the stolen harp has an index of 2. So to access and print the first element in our array, we write print items, and then we access the first element, which has an index of 0. And this spells out potion. Pretty cool. We can just as easily change elements. This changes the second element to smithy sock, and the third element to staff. And arrays also have functions for finding, removing, or adding new elements. So to remove at an index, we write remove add, and then the index 1, this removes the smithy sock. And to add a new element, we write dot append, and we'll append an overpowered sword to the end of the array. Now, arrays can quickly become long and difficult to manually go over. Luckily, we can use something called loops to help out. Loops. Loops allow us to repeat code a number of times with small variations.
Simple,
they are perfect for
flexible.
iterating through all the elements in an array. If, for example, we wanted to print out all the items in our array here, we can do that easily by using a for loop. So we write for, then the name of the item that we're currently looking at, we'll just name that item in the array, so in items. We will print out the current item we're looking at. So print item. And as you can see, it prints potion, feather, and stolen harp. This is cool because we can have any number of items in our array. The code will work just fine. We can also add more functionality, say to only print items that are more than 6 letters long. If
I wonder if loops also allow us to get the index.
item.length, so the amount of characters in item is greater than, let's say, 6, then we're going to print that item. And now it only prints feather and stolen harp because potion is exactly 6 letters. We can also create loops that run a certain amount of times. If we write for n in 8, it creates a for loop where the variable n starts at 0, then goes all the way to 7. So if we print n, we can see that it runs 8 times, and n starts at 0 and ends at 7. We say that n is the current iteration of the loop. Another type of loop is the while loop. This repeats as long as a certain condition is met. Now, I think most people who know me would say that I'm a glass half full kind of person. And to those who disagree, let me go ahead and prove it by using a while loop to fill up a glass halfway. So I'll create a glass variable and default it to 0.0. The glass is currently empty, no arguing about that. Then we'll create a while loop that continues while glass is less than 0.5, so we haven't filled it up halfway yet, in which case we will add a certain amount to our glass. We could do a constant amount like this, or in real life, when I try to pour something into a glass, I'm not that precise, so let's add a random number instead. So we'll add a random float between 0.01 and 0.2, and then we'll print out how much is in the glass at the current time. Then when the loop is done, we get to continue down here in our code, and we'll print that the glass is now half full. And if we run this, we can see that the glass slowly becomes more full with a random amount each time, and then it says that the glass is now half full. As you can also see, it overshoots a bit because we're adding a random amount each time and not climbing the value, just like when trying to hit exactly half a glass in real life. My wife says that I add too much milk when I make her coffee. I think I'll refer her to this going forward. Now, we actually have to be really careful when using while loops that we don't create an infinite loop. These can be tricky to avoid and can very easily crash our program. Say if I were to remove this line that adds a little bit to our glass every time, well then our glass would actually never become half full and we would be stuck in this loop forever. Now, I don't think this will actually crash Godot. Indeed, it didn't, but we get a lot of overflow errors. And as you can see, our game is definitely not responding. Not good. Finally, in both for and while loops, we can use the break and continue keywords. Break, as the name suggests, breaks out of the loop and moves on to the code after, while continue immediately skips to the next iteration of the loop. So if we...
Another question, do we have labels for break? Because it's often, especially in games, that you have a loop within a loop, and you just want to skip the whole thing. So having labels would be awesome too.
we were to write if glass is greater than 0.2 and then break, we can see that our while loop ends way early because
I actually want to check that like ASAP because there must be a way to find it, right? Let's see. Scripting, programming languages, GD script. We have a reference that goes over basic stuff. What do we have here? Identifiers, keywords. We have break. And that's all we have here. Operators. No, this is a short document. Literals, sure, annotations, comments. It doesn't seem like there's a multi-line comment. That is interesting. I'm honestly surprised. I guess they don't expect you to write a lot of comments, right? Line continuation, yeah, built-in types, all that stuff. Array, packed array, dictionaries, signals, callable, data variables. I'll need to read through that 100%. Static variables, a class member variable can be, a class member. Nice. That means that all the instances share it. Nice. Blah, blah, blah. Static unload. We'll get through that at some point. Constants, enums. Okay, we've got enums, functions. Referencing functions of callable, yeah. Lambda functions. Do they look like lambda functions? Not really, but good enough. Static functions too. Okay, that's absolutely awesome. Okay, so now we have control flow now. If else, well, for loop. And for loop, can we get index? No. Nope. Come on, you could just add a comma something to have index in for loops. That would be so helpful. And would probably improve performance in some way. Because you wouldn't need to write as much Godot script to have separate operation to get the thing and have the index. You just have one thing and get both at the same time. It'll be faster too. Good matching. What about breaking from the while loop? Pattern guards, classes, inheritance. But there's no like. Did we skip the while loop? We have setters, getters, while loop. While. Let's see, there are not too many while. Okay, while. Using break. Also, there's no like. There's something more about break. This breakpoint, break. Oh, that's it. Too bad. Too bad we don't have more fun stuff.
We exit out of the loop before we even get to print that the class reached 0.2. Dictionaries. They sound really boring, but they're really cool. While arrays are great for storing lists of elements, it's sometimes confusing to access each element with an index. Sometimes it makes more sense to use a dictionary. Dictionaries hold what we call key-value pairs. Let me explain. In real life, we use a dictionary to look up the definition of words in a language. The key in this instance is the word we're looking up, and the value is the and set it equal to some curly brackets. This is an empty dictionary. We can then add key-value pairs inside the curly brackets. Say, for example, that we have multiple players in our game. We can use a dictionary to keep track of them. Each player has a username. This will be the key, and the level. This will be the value. So I'll create a player called Crook, and his level is going to be 1. I'll create another player, Villain, with a level of 35. And finally, a player with the username boss with a level of 100. If defining on one line becomes too much, you can split it up like this. And it's good practice to add a comment to the last entry so you're ready for a new one. And let's name this dictionary players. Then to get the level of a player, we simply type in the username. Let's print the level of our villain. So print, and we'll write players, type in villain, and this should print 35. And you can just as easily assign a new value or add another entry. So we can reassign the villain here to say 50 and add a new entry called Dwayne with a whopping level of 999. And just like with arrays, we can loop over a dictionary with a for loop. When we do this, we're actually looping over all the keys in our dictionary, so all the usernames. And for each username in players, we will go ahead and print out the username. I'll add a string to separate, and then the level. So here we access our player's dictionary and input the username we're currently looking on to get the value. And remember to convert this into a string, so str, to cast to a string. There you go, it prints our entire dictionary inside another dictionary. This might sound really abstract, but it's actually pretty cool and often comes in handy. Say, for example, we don't just want to store the level of each player, but also other info like their health. Well, then we simply replace this value with another dictionary. So open and close some curly brackets. Here we'll add a key called level with a value of 1, and another key called health with a value of 80. And at this point, it's a good idea to use tabs to keep our code clean. Let's duplicate this. I'll assign some values. And now we can access a value by using two keys. Let's print the health of our boss, so print players. We go into our boss, and we access the health. And this prints 500, which is correct. So this way we can start to think of ways we can structure data about what's going on in our game, such as player stats, inventory, buffs, and so on. Enums. Enums are a convenient way to define tags or states in our game. Say we're making a game with a bunch of units, and we want a way to mark each one as either hostile, neutral, or ally. In this case, we could create an enum that defines these tags. So at the top here, I'll write enum to create a new enum, and then in the curly brackets, I'll write ally, neutral, and enemy. And now we can use these states in our game. For example, we can create a variable called unit alignment and set it equal to any one of these states. I'll just set it to ally. And this makes it really quick and easy to then check in our code if our unit has a certain alignment.
So it's just keyword enum values, and can we assign extra specific values
So
to
let's just give our enum a name here to stay organized. So I'm going to call this alignment. And now whenever we are accessing a state, we have to go inside of alignment dot, and here you can see our state. So I'll go alignment dot ally by default. And then inside of ready, we can check if unit alignment is equal to alignment dot, let's check for enemy. And if it is, we will print you are not welcome here. And if it's not, so it's not an enemy, we'll just write welcome. And now if we run, we can see that our console displays welcome because our unit alignment is currently ally.
So it's interesting that you don't have to specify the name. I guess this way you would be able to specify, just have this locked down to a specific class, and then I think something else was also specifying it where you could just do name of the class and then name of the thingy without specifying that this is alignment or something else.
This is much safer than using, say, a string or an integer to represent states, because Godot will throw an error if we misspell a state. If, for example, I misspell enemy, we can see that Godot throws an error. But I think one of the real powers of enums is that we can use them for exported variables. To do this, we mark our variable here with export, and then set the type to alignment. And now we can actually set our unit alignment in the inspector. So I'm going to set mine to enemy here, and now when we play, it prints you are not welcome here. Really cool. Now what's actually happening behind the scenes here is that Godot is creating a constant for each state in our enum. So this code here is actually completely identical to our first line. And as you can see, the value here increases from 0 to 1 to 2, kind of like an index. So an enum is essentially just a bunch of constants with an increasing value, which means that if we try to print one of these states, say we print alignment.enemy, the console simply shows the value of that constant, which is 2, because it's the third state. This is rarely something you need to take into account, but it's nice to know what our code is actually doing. And we can even override the default value if we want. So we could set ally equal to 1, neutral equal to 0, and enemy equal to -1, and now our console displays -1 because that's now the value of our enemy constant. Now something that pairs really nicely with enums are match statements because they allow us to quickly add functionality for each state. Match is the Godot equivalent of the switch statement from other languages. It allows us to execute different code depending on the value of a variable. In this case here, we can use a match statement to add some code for the different values of our enum. So I'll write match, then the variable we are matching based on, which is my alignment, colon, and now we add code for each value. So in case my alignment is alignment.ally, I'll print hello, friend. If it is neutral, I'll print a common piece. If it is enemy, taste my wrath. And a cool thing here is that we can actually add a default response as well. To do that, we do _:. And so if it isn't any of the cases above, we'll print who art thou? And if we set my alignment to say enemy, taste my wrath. Modifying nodes 2.0. So far, when we need to access a node, we've done so by simply dragging it into our script, which creates a $sign followed by the path to the node. I've created a few empty nodes here to demonstrate. A player node with a graphics and weapon node, and an enemy node. So if I drag in the weapon node, it creates a path that goes into the player and finds the weapon. And we can actually store this reference in a variable. To do this, we simply drag it to the top and hold down Control while releasing. This automatically creates a variable with the name of the node and the correct path. And as you can see, it uses the onReady keyword. This is because Godot has a very strict order in which nodes are created. And if we open the game and try to find the weapon node before it exists, we will get an error. OnReady simply makes sure that Godot waits until all child nodes have been created so we don't get any issues. And just a quick note, the $sign here is actually just shorthand for using the getNode function. So this is actually identical. Also, you might have noticed that the path is relative. Our script is on the main node, so it starts right after that node. We can print the absolute path through script. We'll print weapon.getPath. This prints the absolute path starting from the root of our game all the way to weapon. Now paths are great for many things, but sometimes they can be a bit inflexible. They break if we rename any of the nodes in the path, and it's best to only use paths when the node we want to access is a child of the node we're working on. We'll talk more about parent-child relationships later. Luckily, we can also use the export keyword to reference other nodes. So if we write export and create a variable called myNode, we can set the type to node. And then in the inspector, we can assign whatever node we want, or simply click and drag. I'll drag in the player. We can also check if the node is a certain type by using the is keyword. So in ready, we'll check if my node is of type node2D, in which case we'll print is 2D. And it is. We can even be specific about what type of node we want to be able to reference. If, for example, we only want to reference sprite nodes,
Okay, I like the checking for type. Just is something, and we can probably use inheritance here.
We just change the type to sprite. So sprite 2D. I'll reset the variable here, and now we can only assign sprites, which in this case are the graphics and weapon nodes. Now, if we play, it still prints that this node is a 2D node, even though sprite 2D and node 2D are two different nodes. This is because sprite 2D inherits from node 2D, but we'll get into that in the inheritance chapter. Signals. Signals are messages that nodes can send to each other. We use them to notify that a certain event occurred. It's probably easiest to look at an example. Godot has many built-in signals. Take this UI button. If we select it and go to node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double-click it, I'm going to select main, and hit connect. As you can see, this creates a function called onButtonPressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here, and now if we play and press the button, it prints money. Get it? Now this is because whenever we press the button, it emits the pressed signal, and everything connected to it gets called. In this case, our onButtonPressed function, which indeed prints money. We can connect as many functions as we want to a signal. They will all be called when it gets emitted. This is really cool because it allows us to link together nodes in a way where they don't have to be aware of each other. The button has no idea which functions are connected to the signal. It just tells it to emit. This makes signals great for separating different parts of our game, or decoupling. Say we're playing a character that can level up by getting enough XP. Whenever we level up, there are probably many game systems that need to update. The UI, our player stats, perhaps we have spells or achievements that unlock, and updating all of these from the player can quickly become a mess. Instead, we create a leveled up signal that all these systems can connect to. Then all we need to do is have the player emit the signal when we level up. Let's try it out. Instead of a button here, I'll create a timer. So I'll add a timer node and set it to auto start. This will count down from 1, and when it reaches 0, it emits a signal called timeout. Let's connect that to our script and make it increase our XP. So we'll create an XP variable, default it to 0. Then in our function, we increase our XP, and let's also print it. If our XP then reaches, say, 20, we'll set it back to 0, we leveled up, and we can start over for the new level. And if we then play, it's going to increment our XP every second, and when we reach 20, it's going to go back to 0. Now let's create a signal that other nodes can connect to. So at the top, we'll write signal, leveled up, and if we save this and select our main node, we can actually see that signal. We can connect it to other nodes, but just for this example, we'll connect it back to our main node. This creates an onLeveled up function, which is called when the signal is emitted. Let's print a message that says ping. Now we simply have to emit the signal. Let's do that when we reach 20 XP. Here we'll write leveled up dot emit. Now when we reach 20 XP, it emits the signal, and we print ping. Awesome. We can also connect signals through code. I'll disconnect the signal in the editor, and instead in a ready function, I'll write levelup.connect and the name of the function we're connecting to, on leveled up. Careful here, this will probably autocomplete with parentheses. We don't need those, we just want the name of the function. And disconnecting is just as easy, disconnect. We can also pass parameters through signals. This could be used to pass the level we reached or other useful information. I'll just add a quick message that we can print. So on a signal, we'll add a parameter. We'll make sure that our function supports this as well. And instead of printing ping, we'll print whatever message was input. And then when we emit the signal, we can put in a message. Let's put in grats. And voila, it displays grats. And that is signals. Get, set, go. Or just get set. Getters and setters allow us to add code for when a variable is changed.
I'm actually surprised there's a get set, considering all the, how basic some stuff is being kept. Suddenly we have getters and setters.
This means that we can do things like clamp a value within a certain range, or emit a signal letting other parts of our code know that the variable changed. The example that is always used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to, and now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp it first between 0 and 100. So this makes sure that our health does never exceed 100 or go below 0. We could also emit a signal here, so we can create a signal. Health changed, and we can actually input the new health as a parameter, and then in our setter we can go health changed dot emit and put in the new health. Of course, we need to make sure to connect this signal. We can do that through the editor, and let's just print the value. So we'll print the new health. Then in ready, let's try this out by assigning a value to health. Let's try assigning -150, and now if we play, we can see that it prints 0. This is because we put in -150. It clamps this to 0, and then it emits the signal. The signal then calls the onHealthChanged function, and we print the new health, which is 0. So that's a good example of adding a setter. Getters are more commonly used to convert values. So let's add two variables. We'll have a chance that is equal to 0.2, and then we can have another one, which is our chance in percent. We'll make this of type int, and we will add a getter. Here, whenever we try to get the chance percentage, we'll simply return the chance variable times 100. And now if we try to print this variable, print chance percentage, or change our chance to, let's say, 0.6 and print it again, we can see that our chance percentage is completely based on whatever our chance is currently equal to. And so it starts at 20% and then goes to 60%. And for good measure's sake, we'll add a setter also. So if we set to a new value, we will modify our chance and set it equal to the new value divided by 100. And since our chance is a float, we'll make sure to cast that value. So now instead of changing the chance, we can directly change the change percentage to say 40. There we go. Classes. This is a good one. GDScript is an object-oriented programming language. This means that we generally try to structure our code in self-contained objects that interact with each other. We primarily do this using classes. For now, try to think of a class as a blueprint. Say, for example, we're making an RPG and we need to populate it with a bunch of characters that the player can interact with. So we create a character class that has some variables and logic that all characters in the game should have. So for variables, we could add things like name, health, and a line of dialogue for when you interact with them. For logic, we could add functions like talk and die. Then we take this class and create instances. Instances are specific versions of the class. So we could create an instance named Potion Seller that has a health of 50, and a line that says, you can handle my strongest potions, and a bunch more instances, all of which have the same variables, but different values, and all of which can talk, I used to be an adventurer like you, and die. So that's the idea of classes. In Godot, you've actually already encountered a bunch of classes. That's because all the built-in nodes in Godot are classes, which actually makes a lot of sense if you think about it. All the nodes are self-contained objects with a bunch of variables and logic that we can create instances of. If we add a sprite node, we're instancing the sprite class. So when we create a script, we're actually also creating a class. I have to put a disclaimer here that we're technically not creating a class, but for all intents and purposes, it works just like one. So let's forget all about that for now. So let's abandon our main script here for now and instead create a new node. So let's search for node, and let's name this node character and add a script to it. Now to make it more clear that our script is a class that defines a character, let's set the class name to character. So right at the top here, we'll go class name, character with a capital C. And we can now add some variables. We'll mark these with export so that we can set them in the inspector for each character instance. So export var. Let's add a profession of type string and give each character a health as well of type integer. And so now we can see that our character here has these two properties in the inspector, and we can go ahead and fill out the profession. This is going to be the potion seller, who is going to have a health of, let's say, 40. And now we can create more instances by duplicating this node. So let's duplicate it a few times. The second character here will name X Adventurer with a health of 30. And the last character will be our knight, and we'll give him a health of, say, 150. So now we have these three instances with different properties, and we can also give them a function. So let's add a die function. So I'll write func die, and this function is going to set our health to 0, as well as print our profession and the fact that we died. And that's it for our character class, but currently nothing is triggering this function. So let's go into our main script now, and here we can get a reference to one of our characters and call the die function. We could simply drag and drop one of these nodes to get a reference, but because we have named our class, we can actually use an export variable for this instead. This way we can set the connection in the editor, and we don't have to worry about the path changing. So we'll write export var, and here we'll have a character to kill of type character. And now if we save that, we can see that our main node now has a slot here for the character to kill. We can either drag in one of these characters or hit assign and select one. I'm going to choose character 3. And now in our ready method, we simply go to our character to kill and call the die function. And if we run this, indeed, the die function is called on our character 3, which is our knight. So it says knight died. And if we choose another character, say the first one, we are instead killing the potion seller. Really cool. Inner classes. These are classes that exist inside of another class. We mostly use these for bundling together variables and maybe add a function or two. They can be a good alternative to dictionaries because they are sometimes a bit more safe to use. Say we have this character class here and we would like to add some equipment. We could create an inner class called equipment. So I'll write class equipment, and then we can give it a couple of variables. I'll create an armor variable, set it to 10 by default, and a weight of 5. Now we can use this class around our script. So we could create some variables using it. I'll create a chest that is equal to equipment.new. Calling .new will create an instance of the equipment class. So now we have one piece of equipment, one instance, which is a chest. We'll also create legs, and again we'll call equipment.new. Then in the ready function, we can access these classes. So we can go into our chest and change the armor and set it equal to 20. We can then print chest.armor, or maybe print legs.weight. And this is also where you can see that this is sometimes safer than using a dictionary, because GDScript will recognize that there is a weight variable inside of the equipment class. And if we try to access something that isn't there, we'll get an error before playing the game, not only when we reach this point in our code. This is called being type safe. And now if we run this, we can see that each of the instances of our character will print these two pieces of equipment. And the armor of the chest is 20, and the weight of the legs is 5. Inheritance. So we know that all nodes in Godot are classes, and we can effectively make our own using scripts. But there's one more important thing we need to know to understand how Godot is structured: inheritance. Inheritance refers to the ability to derive one class from another. We've actually already been doing this. Notice how our script says extends node. So our script derives from the node class. This means that all the functions and variables of the node class are also available in our script. Godot actually has a very nice way of visualizing this. When adding a new node, we can see all the nodes available to us, but some of these are organized under other nodes. That's because these nodes inherit from the top ones. For example, both animated sprite 2D and camera 2D inherit from node 2D. This is because node 2D is a base class for all things that exist in 2D space. So since both a camera and a sprite needs a position in our world, they both inherit from it. And even cooler, we can actually find our character class on this list as well. That's because when we create a character class, we're essentially defining a new node type, and we can see that it inherits from node. Really cool. Now, all of this probably sounds a bit abstract, because it is. But what it means in most cases is simply that we need to make sure we inherit from or extend the right class for what we're working with. If, for example, we're making a script that moves around our player, we would create a character body node and add a script to that node. We could name it, say, player. And as you can see, this script then automatically extends character body 2D. And we now have access to all the functionality in it, such as the velocity and the move and slide function, which moves the node around. Composition. Now, even though Godot uses inheritance for its nodes, there are often better ways to structure your code. Godot actually leans itself really well to another way called composition. I'm not going to explain that here since there's already a really good video on the subject by a channel called Bitlytic, but I definitely recommend you check that out. Call down, signal up. When writing GDScript, there are of course many best practices that we can choose to adhere to. Going over all of them is a video on its own, but one that is particularly important is call down, signal up, which we use as a rule of thumb when communicating between nodes. Every scene in Godot is a tree of nodes, and the beginning of the tree is called the root node, which is the highest in the hierarchy. When looking at two nodes where one is right above the other, we say that they have a parent-child relationship. The node that is above is the parent, and the node that is below is the child, and that child might also have a child, and so on. Call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy, but not vice versa. Instead, nodes below should use signals to communicate that something has happened. The nodes above can then connect to these signals as they choose and act accordingly. Think of it like real life. Parents are allowed to tell their children what to do, but children shouldn't directly command their parents to do things. Instead, children signal their needs to the parents, and the parents decide the next step. Now keep in mind that this is a way to remember good coding practice. It is definitely not parenting advice. But what if we need to communicate between two nodes that are on the same level? You guessed it, these are called siblings. Well, here the common parent is in charge of connecting the signal from one sibling to the function on the other. This is most often done in the ready function right at the beginning. So that's the idea of the rule, but of course always implementing this concept correctly requires some practice. I'll have a link to a good article with some nice examples. Style. During this video, I've tried my best to adhere to the official GDScript style guide. These are the conventions we use for naming and order to keep our code elegant and readable for others. I won't go into further detail here, but I'll have a link to the official guide. That was a lot of code for one video. Of course, I haven't covered everything you're ever going to.
All right. That was pleasant. Let's say it was pleasant, right? So, okay. I dig it. I dig it. I like getters and setters. That's going to help out a lot with, setting things that should, let's say, notify the UI. Especially in various global situations. I'll need to explore more of the static options too, which is good to know that they exist. What else was interesting? Yeah, just having, little inner classes, that might help a lot. I also wonder how to define classes that are not inheriting from nodes or whatever. Just to define them. I wonder if all that needs to happen is for them to be available somewhere in here. I don't know if there would need to be an auto load. So okay, hey, that's good. So because tomorrow what I would like to do is go through, because I will be scheduling a stream for tomorrow for, you know, more prepping for with Godot. I would like to do something like what was it, GMTK platformer toolkit or something like that. Yeah, tomorrow I would like to look at this whole platforming toolkit to just kind of jog my memory on how those things are supposed to work and how they feel, and how maybe we could try to recreate it somewhat in Godot. That would be probably a fun thing to do. So I would like to do that. So today we're gonna go over the manual, just overall the manual for the Godot, starting with best practices. And what version I'm on? I'm on the stable. I want to go to latest. And why? Because I'm using Godot 4.3. And, you know, it's... Oh, this got updated. It already shows that it's Godot 4.3. Look at that. That wasn't here yesterday, I think. Yesterday was still showing 4.2. So, yeah, latest. There we go. Is there anything else? There's 4.2, which is stable. Yeah, but we are only doing 4.3. So I guess the RC3, the release candidate 3, happened, and now the work on documentation begins. So that's cool. So let's just go through best practices to just start learning how to approach various tasks. Introduction. This series is a collection of best practices to help you work efficiently with Godot. Godot allows for a great amount of flexibility in how you structure a project's code base and break it down into scenes. Each approach has its pros and cons, and they can be hard to weigh until you've worked with the engine for long enough. There are always many ways to structure your code and solve specific programming problems. It would be impossible to cover them all here. That is why each article starts from a real-world problem. We will break down each problem in fundamental questions, suggesting solutions, analyze the pros and cons of each option, and highlight the best course of action for the problem at hand. You should start by reading Applying Object-Oriented Principles in Godot. It explains how Godot's nodes and scenes relate to classes and objects in other object-oriented programming languages. It will help you make sense of the rest of the series. Cool. So, is that next? Yes, that's next. How convenient. Applying Object-Oriented Principles in Godot. The engine offers two main ways to create reusable objects: scripts and scenes. Neither of these technically define classes under the hood. Interesting. Because when you create a script, it kind of shows as if you were extending a class, right? Still, many best practices using Godot involve applying object-oriented programming principles to the scripts and scenes that compose your game. That is why it's useful to understand how we can think of them as classes. This guide briefly explains how scripts and scenes work in the engine's core to help you understand how they work under the hood. So, how scripts work in the engine? The engine provides built-in classes like Node. You can extend those to create derived types using a script. These scripts are not technical classes. Instead, they are resources that tell the engine a sequence of initializations to perform on one of the engine's built-in classes. Godot's internal classes have methods that register a class's data with a class DB. This database provides runtime access to class information. Class DB contains information about classes like properties, methods, constants, and signals. Okay, so this is basically a reflection system. So I presume when we create a script, we just say, okay, this is a script that's gonna take that description of this class, like a node 2D or something else, right? Or a sprite. And then we can add basically additional stuff to it, like this variable or maybe that method. So we are not really in a script, we're not really creating a new class. We're just saying, okay, for something of this type, something called, I don't know, my animated sprite 2D, we are just registering additional name of a method that leads to some kind of abstract implementation that's really unrelated, or a constant, or some property, or signals, and whatnot. Okay, I see it. And this class DB is what objects check against when performing an operation, like accessing a property or calling a method. It checks the database's records and the object's base types. Records to see if the object supports the operation. Attaching a script to your object extends the methods, properties, and signals available from the class DB. Okay, so it basically registers that, oh, for this node, additionally, you have this and that and that. And that's all it does. Even scripts that don't use the extends keyword implicitly inherit from the engine's base refcounted class. As a result, you can instantiate scripts without the extends keyword from code, since they extend refcounted through and cannot attach them to a node. All right. I see. Scenes. The behavior of scenes has many similarities to classes, so it can make sense to think of a scene as a class. Scenes are reusable, instantiable, and inheritable groups of nodes. Inheritable, you say? I guess if you have a scene that internally has a bunch of children, and you can still attach children to it, right? Even though you imported just this whole scene. Creating a scene is similar to having a script that creates nodes and adds them as children using the add child. Okay. We often pair a scene with a scripted root node that makes use of the scene's nodes. As such, the script extends the scene by adding behavior through imperative code. The content of the scene helps to define what nodes are available to the script, how they're organized, how they're initialized, and what signal connections they have with each other. Why is any of this important to scene organization? Because instances of scenes are objects. As a result, many object-oriented principles that apply to written code also apply to scenes, single responsibility, encapsulation, and others. Yep. The scene is always an extension of the script attached to its root node, so you can interpret it as part of a class. Most of the techniques explained in this best practices series build on this point. Okay, this is pretty straightforward. I like it. At least we know straight ahead that, okay, everything we're doing is basically just operating on a reflection, not the actual classes. Good. That will explain why some things are less performant, but at the same time, it explains why it's so easy to extend stuff. Yeah. Good approach, I'd say. Decent approach. Unreal Engine does a lot of that on its own, too. So why not? All right, scene organization. This article covers topics related to effective organization of scene content. Which nodes should you use? Where should you place them? How should they interact? When Godot users begin crafting their own scenes, they often run into the following problem. They create their first scene and fill it with content, only to eventually end up saving branches of their scene into separate scenes, as the nagging feeling that they should split things up starts to accumulate. However, they then notice that the hard references they were able to rely on before are no longer possible. Reusing the scene in multiple places creates issues because the node paths do not find their targets and signal connections established in the editor. And signal connections established in the editor break. Yep. Hello, Taras. How are you doing? Because I am back to reading manuals, this time for Godot. To fix these problems, you must instantiate these subscenes without them requiring details about their environment. You need to be able to trust that the subscene will create itself without being picky about how it's used. One of the biggest things to consider in OOP is maintaining focused singular-purpose classes with loose coupling to other parts of the codebase. This keeps the size of objects small for maintainability and improves their reusability. Tessa is doing good. Mostly rested this weekend. That's awesome to hear. It's good to rest from time to time. As you can see, I'm resting by learning, which I like that method of rest, to be honest. Feels good. These OOP best practices have several implications for best practices in scene structure and script usage. If at all possible, you should design scenes to have no dependencies. That is, you should create scenes that keep everything they need within themselves. If a scene must interact with an external context, experienced developers recommend the use of dependency injection. This technique involves having a high-level API provide the dependencies of the low-level API. Why do this? Because classes which rely on their external environment can inadvertently trigger bugs and unexpected behavior. And sometimes it feels like in game development it's so much easier to introduce bugs than working with web or something else. Mostly because you have so many tools available and they are often loosely connected that, compiler has no clue what you're doing. Alright, to do this, you must expose data and then rely on the parent content to initialize it. Connect to a signal. Extremely safe, but should be used only to respond to behavior, not start it. By convention, signal names are usually past tense verbs like entered or skill activated or item collected. So we can see that in GDScript, we do, child.signal name connect. So we basically have signal and we call connect on it and we pass it the other method that already exists on the object. Okay. So this way we're basically hooking up the signal in the child to whatever we have on the parent. While in the child, all we need to do is signal name emit. This way the child itself has no clue what the parent is, how the parent works, what nodes are in the parent. The child only worries about whatever's inside of it, which is always a good thing, right? So we connect and call a method used to store behavior. So child.method name is do, and child, assuming it has a string property method name, and method do, call method name. Okay, call parent defined method, which child must own. This is a little bit confusing, just a little bit. So this method do is already on a child. So I guess in a child I could specify few various methods and the parent can choose which ones is supposed to be called. But then I wouldn't be doing it this way. I would just specify it more through some kind of, specify a variable or something, like an enum rather than specify this. A strange approach. Initialize a callable property. Safer than a method ownership, as ownership of the method is unnecessary. Used to start behavior. So what it means is that the parent can say child, func property is object with method, so some other object or maybe itself or whatever, and the method. So we can basically pass the method or a function as an argument, or save it as a variable, and then we can simply call it. All right, that's simple. And that's, like, callbacks or a bunch of other stuff. So this is very, extremely very useful. Initialize a node or other object reference. So parent, child, the target is self. So parent assigns self as a target, and then child can do something with that target. So we injected something to it, right? Either a function or connection to a signal or actual reference to something, right? Or initialize a node path. So parent child dot target path is just dot dot or something. So we can just give it a path and it can extract the node itself. I'd prefer that personally. Unless we just need to give it maybe a path or node to a node that contains more stuff, and then yeah, child can do something with it. These options hide the points of access from the child node. This in turn keeps the child loosely coupled to its environment. You can reuse it in another context without any extra changes to its API. Perfect. Although the examples above illustrate parent-child relationships, the same principles apply toward all object relations. Nodes which are siblings should only be aware of their own hierarchies, while an ancestor mediates their communications and references. So you should try to make a game. Okay, so we have parent. Left target is right the get node. Yep. And then left one can just grab the target and execute something with the target, while the right one can register receiver, whatever. Sure. Into that node. All right, so yeah. Basically, the whole thing is that the parent should be managing the connections that are even between its own children. Therefore, none of those needs to be aware of the other one, right? The same principles also apply to non-node objects that maintain dependencies on other objects. Whichever object owns the other objects should manage the relationships between them. Warning, you should favor keeping data in-house, internal to a scene. Though as placing a dependency on an external context, even a loosely coupled one, still means that the node will expect something in its environment to be true. The project's design philosophies should prevent this from happening. If not, the code's inherent liabilities will force developers to use documentation to keep track of object relations on a microscopic scale. This is otherwise known as development hell. Writing code that relies on external documentation to use it safely is error-prone by default. Yep. To avoid creating and maintaining such documentation, you convert a dependencies node, like child above, into a tool script that implements get configuration warnings. Interesting. Returning a non-empty packed string array from it will make the scene doc generate a warning icon with the strings. All I need to do is just add this, register this function. Really? Can I do that? We have this scene, right? This node where I have this script. So all I need to do is say we have this function. Return non-empty packed string array. Or array packed string array. Can I just do this? Return error array. Okay, that works. But what if I'm gonna do array append there? There's always a problem. Okay, save it. And no, it didn't work. It's not that easy, I think. Yeah, this still shows that there's no problem. Convert it into a tool script. How do you convert it into a tool script? The elements in the array returned from this method are displayed as warnings. Okay. Call update configuration warnings when the warnings need to be updated for this node. So we've got this and I don't think onReady will do anything. A more interesting example would be fun. Let's go back here. Let's just give it this. Oof. And save. Nope, we won't get any warnings. We'll update this. Still no warnings. Huh. And how was this created here? I just returned this and doesn't even matter. I don't need to mark it as anything special. So return this. Save. This. Oh, we're not getting errors. Too bad. Okay, but I guess we could read about it later in the future a little bit. So, okay. So returning a non-empty packed string array from it will make the scene dog generate a warning icon with the strings as a tooltip by the node. This is the same icon that appears for nodes such as Area 2D or when it has no child, collision shape 2D. Okay. The editor then self-documents the scene through the script code. No content duplication via documentation is necessary. Perfect. A GUI like this can better inform project users of critical information about a node. Does it have external dependencies? Have those dependencies be satisfied? Other programmers, and especially designers and writers, will need clear instructions and messages telling them what to do to configure it. Alright, I really like that approach. Just wish it worked. Or I knew how to use it because this doesn't seem to be enough. Oh well. So why does all this complex switcheroo work? Well, because scenes operate best when they operate alone. If unable to work alone, then working with others anonymously with minimal hard dependencies, for example, loose coupling, is the next best thing. Inevitably, changes may need to be made to a class, and if these changes cause it to interact with other scenes in unforeseen ways, then things will start to break down. The whole point of all this indirection is to avoid ending up in a situation where when changing one class results in adversely affecting other classes dependent on it. Scripts and scenes as extensions of engine classes should abide by all OOP principles, and examples include Solid, Dry, Kiss, and Yagni. Yep. So, don't remember what that stands for. Do not repeat yourself. Keep it simple, stupid, and you ain't gonna need it. Choosing a node tree structure. You might start to work on a game, but get overwhelmed by the vast possibilities before you. You might know what you want to do, what systems you want to have, but where do you put them all? How do you go about making your game is always up to you. You can construct node trees in countless ways. If you aren't sure, this guide can give you a sample of a decent structure to start with. A game should always have an entry point. Somewhere you can definitely track where things begin so that you can follow the logic as it continues elsewhere. It also serves as a bird's eye view of all other data and logic in the program. For traditional applications, this is normally a main function. In Godot, it's the main node. Node main. The main.gd script will serve as a primary controller of your game. Then you have an in-game world, a 2D or 3D one. This can be a child of main. In addition, you will need a primary GUI for your game that manages the various menus and widgets the project needs. So we could have the node main, right, with the main.gd script. And in there we have, let's say, node2d world with its own script, like game world. And then we have control GUI with the separate GUI script. And this way you can start, doing things. When changing levels, you can then swap out the children of the world node. Changing scenes manually gives you full control over how your game world transitions. The next step is to consider what gameplay systems your project requires. If you have systems that track all of its data internally, should be globally accessible, and should exist in isolation, then you should create an autoload singleton node. Yeah. Okay. For smaller games, a simpler alternative with less control would be to have a game singleton that simply calls the scene tree change scene to file method to swap out the main scene's content. This structure more or less keeps the world as the main game node. Any GUI would also need to be either a singleton, a transitory part of the world, or manually added as a direct child of the root. Otherwise, the GUI nodes would also delete themselves during scene transitions. If you have systems that modified other systems' data, you should define these as their own scripts or scenes, rather than autoloads. For more information, see autoloads versus regular nodes. So that will be probably some next read. Each subsystem within your game should have its own section within the scene tree. You should use parent-child relationships only in cases where nodes are effectively elements of their parents. Does removing a parent reasonably mean that the children should also be removed? If not, then it should have its own place in the hierarchy as a sibling or some other relation. In some cases, you need these separated nodes to also position themselves relative to each other. You can use the remote transform / remote transform 2D nodes for this purpose. They will allow a target node to continually inherit selected transform elements from the remote node. To assign the target node path, use one of the following: a reliable third party, likely a parent node, to mediate the assignment, or a group to pull a reference to the desired node, assuming there will only ever be one of the targets. Or if you have some extra logic for extra targeting or something. Okay, that's really good to know. There's remote transform. So few things from few different systems can basically, be in the same spot, I guess. Let's say one system would be to have, something that manages a player, and the other system that manages, let's say, a car. And therefore, you could make something like a The target will be, let's say, the car seat, and the player would be able to assume that remote transform. The player is attached to that seat without actually being inside of the car scene, right? There are two different scenes, yet the player can pretend that it exists there. So yeah, that's the use case there. When you should do this is subjective. The dilemma arises when you must micromanage when a node must move around the scene tree to preserve itself. For example, add a player node to a room. Yeah, sure. Need to change rooms, so you must delete the current room. Before the room can be deleted, you must preserve and or move the player. If memory is not a concern, you can just create a new room, move the player to the new room, and delete the old room. While if memory is a concern, instead you will need to move the player somewhere else in the tree, then delete the room, associate and add the new room, and then re-add the player to the new room. So, you suddenly need to do a bunch of those steps. The issue is that the player here is a special case where the developers must know that they need to handle the player this way for the project. The only way to reliably share this information team is to document it. Keeping implementation details in documentation is dangerous. And by documentation could be also, comments in the code. You actually need to read through it to know that, oh wait, I need to do it this weird way or something for that weird reason. It would be nice if there was no such thing. It's a maintenance burden. Strains code readability and unnecessarily bloats the intellectual content of the project, because the less you have to think about the reasons why things happen or like strange steps I need to take, the easier it is to reason about the game. In a more complex game with larger assets, it can be a better idea to keep the player somewhere else in the scene tree entirely. This results in more consistency, no special cases that must be documented and maintained somewhere, and no opportunity for errors to occur because these details are not accounted for. In contrast, if you ever need a child node that does not inherit the transform of its parent, you have the following options. The declarative solution places a node in between them. Since it doesn't have a transform, they won't pass this information to the children. And the imperative solution, use the top level property for the canvas item or node 3D node. This will make the node ignore its inherited transform. Okay. If building a network game, keep in mind which nodes and gameplay systems are relevant to all players versus those just pertinent to the authoritative server. For example, users do not all need to have a copy of every player's player controller logic. They only need their own. Keeping them in a separate branch from the world can help simplify the management of game connections and the like. Because if you have them inside the world, right, all the players with all their player controls, you might think, okay, I'm gonna send over the world, right, to all the players. And suddenly that means that, oh wait, I need to get that world first, ignore all the other player controllers and the stuff. But if you have a world separate from the actual player that the player, is or whatever, you can just say, oh, okay, so I'm gonna play the info about that player and just the world, which includes the player but not their controllers. So, yeah. The key to scene organization is to consider the scene tree in relational terms rather than spatial terms. Are the nodes dependent on their parents' existence? If not, they can thrive all by themselves somewhere else. If they are dependent, then it stands to reason that they should be children of that parent, and likely part of that parent's scene, if they aren't already. Does this mean nodes themselves are components? Not at all. Godot's node trees form an aggregation relationship, not one of composition. But while you still have the flexibility to move nodes around, it is still best when such moves are unnecessary by default. Oh, perfect. Gosh, these are good little tips. I like it. Maybe nothing that suddenly will change how you the game you're developing right now, or like completely change the way you start programming or something, but from the standpoint of how you structure a game, hell yeah. Okay, so let's learn when to use scenes versus scripts. Okay? We've already covered how scenes and scripts are different. Scripts define an engine class extension with imperative code, scenes with declarative code. Each system's capabilities are different as a result. Scenes can define how an extended class initializes, but not what its behavior actually is. Scenes are often used in conjunction with a script, the scene declaring a composition of nodes and the script adding behavior with imperative code. Okay. So we have anonymous types. It is possible to completely define a scene's contents using a script alone. This is, in essence, what the Godot editor does, only in the C++ constructor of its objects. But choosing which one to use can be a dilemma. Creating a script instances is identical to creating in-game classes, whereas handling scenes requires a change in API. So for example, we define constant myNode and we load the script. Okay? My scene is preload the scene. So we take the node is node new. So we created some new node. My node is my node new. So okay, so this preloaded the so this loaded the class itself, whatever description of the fake class. And here we actually instantiated. Here we instantiate a bare node. Here we instantiate the script. And then we take the scene and instantiate the scene. Okay. And therefore, my inherited scene is my scene.instantiate packed scene gen edit state main. Create scene inheriting from my scene. Okay. Also, scripts will operate a little slower than scenes due to the speed differences between engine and script code. The larger and more complex the node, the more reason there is to build it as a scene. Oh, I see, because when we have it as a script, we need to call this, right? This will call several things that C++ needs to do, and then needs to get back here and execute and understand this line, and then it executes it. And then C++ gets back, and you not only need to parse what this means, but also you have that traversal between GDScript code, how to translate it to C++, and get back. This adds a lot of extra work. While if you have a scene, like a packed scene, and you just call instantiate it or just have it in the editor, it doesn't need to go constantly back and forth, because even if in GDScript you're just gonna instantiate a scene, it's just one call. Even though it creates all those nodes and all those other things, it doesn't do it through GDScript. There's no back and forth between C and C++. There's only one time when you actually call this line of code. Okay, so yeah, scenes are definitely faster. And if you have code that does a lot of that, then yeah, it might be very beneficial to actually create a scene with instantiate, just to have a bunch of the stuff already set and configured. And then just modify a few extra things for that specific case with code. So yeah, definitely makes sense. Okay, so name types. So these were anonymous types, right? Because we just define a bunch of stuff, like here, okay, we create a new scene or something. But what are name types? Scripts can be registered as a new type within the editor itself. This displays it as a new type in the code or resource creation dialog with an optional icon. This way, the user's ability to use the script is much more streamlined. Rather than having to know the base type of the script they would like to use, create an instance of that base type, and add the script to the node. Instead of doing that with a register script, the script type instead becomes a creation option like the other nodes and resources in the system. The creation dialog even has a search bar to look it up by the type name. Okay, so there are two systems for registering types: custom types and script classes. Custom types are editor only. Type names are not accessible at runtime. Does not support inherited custom types. An initializer tool creates the node with a script, nothing more. Then we have editor has no type and awareness of the script or its relationship to other engine types or scripts. And it allows users to define an icon. Works for all scripting languages because it deals with script resources and abstract. And in setup using editor plugin add custom type. All script types, they are editor and runtime accessible. Okay, that's a win. Displays inheritance relationships in full. Another win. Creates the node with the script, but can also change types or extend the type from the editor. Okay. Editor is aware of inheritance relationships between scripts, script classes, and engine C++ classes. Another win. Allows user to define an icon. Engine developers must add support for language manually, both name exposure and runtime accessibility. Okay, I see. And this is only for Godot 3.1 and up, so already for a long time existing. I guess this means that Godot 4 also has it. Yeah. The editor scans project folders and registers any exposed names for all scripting languages. Okay. Each scripting language must implement its own support for exposing this information. Great. This is good. Both methodologies add names to the creation dialog, but script classes in particular also allow users to access the type name without loading the script resource. Creating instances and accessing constants as static methods is viable from anywhere. With features like these, one may wish their type to be a script without a scene due to the ease of use it grants users. Those developing plugins or creating in-house tools for designers to use will find an easier time of things this way. Sure. On the downside, it also means having to use largely imperative programming. Okay, so performance of script versus packed scene. One last aspect to consider when choosing scenes and scripts is execution speed. As the size of objects increases, the script's necessary size to create and initialize them grows much larger. Creating node hierarchies demonstrates this. Each node's logic could be several hundred lines of code in length. The code example below creates a new node, changes its name, assigns a script to it, sets its future parent as its owner, so it gets saved to disk along with it, and finally adds it to the child of the main node. And we basically have this code. Create a child, set name, load a script, add it as a child, and set the owner. Script node like this is much slower. Script code like this is much slower than engine side C++ code. Each instruction makes a call to the scripting API, which leads to many lookups on the backend to find the logic to execute. Scenes help to avoid this performance issue. Packed scene is the base type that scenes inherit from. defines resources that use serialized data to create objects. The engine can process scenes in batches in their backend and provide much better performance than scripts. Exactly. So conclusion. In the end, the best approach is to consider the following. If one wishes to create a basic tool that is going to be reused in several different projects and which people of all skill levels will likely use, including those who don't label themselves as programmers, then chances are that it should probably be a script, likely one with custom name and icon. If one wishes to create a concept that is particular to the game, then it should always be a scene. Scenes are easier to track, edit, and provide more security than scripts. Yep. Like I want to reuse a coin, I want to reuse something else. Instead of having code that generates it, just have it as a scene, even if it's a node with just attached script, already is good enough to just set it as that. If one would like to give a name to a scene, then they can still sort of do this by declaring a script class and give it a scene as a constant. The script becomes, in effect, a namespace. So we have game.gd, class name is game. Alright, it will extend the ref counted, so it won't show up in the node creation dialog. There we go. And we can say const my scene is preload the scene itself. And then in main GD, we can just add child game my scene instantiate. Okay, so yeah, I could have reference to those scenes through code this way. I see. So I want to actually try this out. What if in Godot we're just gonna create a new script? Gonna make it empty. It will inherit from nothing. What does it call it? Ref counted. Let's just specify it. Ref counted. Okay. And we'll call it. What could we call it? Something simple like item. All right. Let's call an item. Extensor of counted, and I want to do the class name is item. Or like, let's do it. Sure, item is good enough. I don't think there's anything else in Godot that's called item, right? And let's say that it has export var. What would be name, which will be just string, and it also has maybe type, which will be some kind of other thing. Let's think. Let's just have it as string first, okay? And then maybe it will be, it could have a lot of stuff, but we could just define function to string, okay? And we can just do return name plus something like this, plus type plus this. So it will print out, name, and just in parentheses will be type. Okay. So does it mean that now when I saved it, can I just go to my node2d and say export var items, which will be basically an array of item? Can I do this? Cannot use simple export annotation because the type of the initialized value can't be inferred. Of course, it's of this type and it's an empty array initially. Save. Export type can only be built in a resource, a node, or an enum. Export type can only be built in a resource, a node, or an enum. Oh, so I can make it a separate item. I see. Okay. Oh, so I will probably need to define items as a resource. How did this define structs? Because it should be easy to build up, structures how you want to build things. And I believe resources are a little bit strange, that you can share them and whatnot. Interesting, but nothing should stop me from doing this, right? Can I do that? Save. It's happy. Okay. And therefore, I can basically say items append, and we'll do item.new, right? So let's do var item is item.new. We're gonna do item.name is, what will that be? Energy items. Jeez. Let me think. Sword. Okay. And item.type is weapon. Okay. So we add it here to the list. All right. And then let's just get rid of all this, all that. That doesn't exist. All right. And then at the end, I would just do for item in items. Let's call this thing new item. Okay. We'll do for item in items. We'll do the item dot. Oh, let's do print item dot to string. And this should work. I hope, at least. Yeah, let's see what's gonna happen when we start the game. Bam! Sword, weapon. There we go. That worked. I already know that I have an error. It needs to have a space after this. But that's it. It just worked. We could probably even add a new static thing. Static function. New item. Right? Or like make. Let's call it make. Okay. That takes a name as string and type as string. And this way we can just do return, or like for item is item.new. Item.name is name. And item.type is type. And return item. Will that work? Static function could not find type string. Oh, yeah. That's the thing. One language is capitalized, the other doesn't, and all that fancy stuff. I don't like that this uses capital S, but oh well. Okay, this worked. So that means that in the node 2D, I could just do item.make, and I'll do, or like, let's have this one here, and we're gonna make new item is item.make, and let's make it bucket. Type will be helmet. Okay. And items append new item, which should add the bucket. So, this already looks nice. And because this is static, we can just call it on any item without doing stuff. So, yeah, a little helper function, right? To create it a little nicer way. Bam, we have sword and bucket. Okay, this works. This makes me very happy. That means that we can connect things nicely. Yeah, awesome. And this thing could probably even keep track of its own stuff, which is var created items, or made items, which will be an array of item. So I'm gonna make it static variable. So this will be not owned, or it should be owned. Parser could not find type item. Oh, capital I. Yeah. So this should be again owned by the class, not by the actual instantiation of the item. Therefore, every time we do make, instead of just returning it, let's just do made items dot append, and this will be what did you call it? Item. Okay. We'll save it here, so they will be saved here. They will be always kept track of. I mean, this is a pointless example, but it's possible. So I could just do this. I could replace this part with, I could probably just do this. Make an item dot make the sword as weapon. Okay. And I can just do item dot made items. Okay. And we should be able to iterate over all of them, even though it's this. And these could be made throughout everywhere. Let's say you instantiate a bunch of them here and there. On ready, everything could, instead of make, maybe register itself, and then you could have this static class that you can basically iterate over stuff that registered itself. So I can see it possible as making those little systems that run in the background, either as those nodes, which could be one option, because they also can have their static stuff and be named, I think. But also as something like this. So yeah, I like that. And when we run, this still prints them both. Or hell, we could actually make it another node, a child node, call it whatever, it's just node 2D, right? And we're gonna assign a script to that too. Wait. How do I remove the script? How do I remove the script? Detach script. Perfect. I want to add a new script, and this will be sub item, right? So now if on a sub item, we're gonna try to call this code instead. Where is it? Here. I could try to get this. This is gonna be an interesting exercise, because if I'm gonna go to that sub item, and on ready, I'm gonna try to print it. Something tells me it's gonna print nothing. Yeah, it printed nothing because at this point there was nothing. Because first the children are created, and on each child the ready will be called. And only then the parent, when it's ready, has all its children ready, then it's gonna call ready. So what we could do is on a child node, we could have creation of this thing, right? Let's say here. Well, iteration of everything would be in the parent. And that should work. That should print it out. There we go. Even though these are two separate scripts, this one is able to collect them. I can even make, so let's say this will be a child 1. And we're gonna create another child. Gonna do child 2. So it's gonna have its own script, sub item 2. And that sub item will just have its own. We had sub item 1 will be the sword. The sub item 2 will do the bucket. And yeah, these all, each own creates its own thing, but both will be printed out because by the time the parent is getting ready, both of them processed. Okay, good. Some things are clicking in my head now. I'll be right back. Short bathroom break. Alrighty, I'm back. So, we still have half an hour left tonight, so yeah, I just wanted to check one more thing, because I just realized when you instantiate a scene, what happens first? Your next line of code, or the ready is being called on that thing you just instantiated? That's something I'm interested in. So let's create a new thing. We'll just call it a 2D scene, and we'll just call it a sword. Okay. And as a child now, I know it should be a main thing, but we'll just add an item. Like, for example, sprite 2D. Okay. Just create that. We don't have any icons here, so I can load the Godot icon. Okay. All right. We're just going to make it thin and duplicate it. And it's going to be like this. And the super sword. Okay. Wait, this and that. You two go here. This is the sword. All right. So we save it as a sword. Okay. So what we're gonna do here is we're gonna attach script. Okay. The sword thing. Create. And the sword thing where I'm gonna actually grab the thing from here. It's gonna register itself as the Godot sword or something. So when ready, it will do how to make Godot sword. Okay. And also we're gonna make it to do print sword ready. Okay. And we're gonna do the first, then we're gonna add the sword thingy. All right. So we just want this to be printed. And then inside our main thingy, in our main node, we have this script. All right. So what we're gonna do is we're gonna get instance of that scene. Okay. Constant sword preload. We just have it hard coded, whatever. And what we're gonna do here is basically for sword is sword.instantiate. So create it. Okay. And then we're gonna do print instantiated the sword. And what's gonna happen first? Are we gonna get the print first? Or are we going to get the inside ready for the sword that's inside that other script? I really want to know. Oh, we have instantiated the sword, but we didn't get ready for the other thing. What? Sword script. Have ready. Print sword ready. It never got printed. What? Why? Didn't we just instantiate it normally? Okay, I must say this is strange. Why was ready never called on the thing? I have a sword. The sword has function underscore ready. Extends node to D, so no big deal here, right? Yeah. Why? What just happened? Is there some kind of error happening or something? Can I just do this and run it? Nothing. Nothing. It just straight up doesn't happen. It just doesn't happen. Ready doesn't get executed. But why? I instantiated the sword. Like in a normal, boring way. Unless... No. It should just happen normally. Oh, because I didn't add it anywhere. I just created an instance, right? And only then I can do add child sword here, right? And print added child. Okay. Let's see what happens now. Bam. Okay. So first we instantiated the sword. Then we started adding the child, which called the ready, and then we actually executed this. Okay, therefore it now showed up here. I see. Okay, so that means that if I did something with the thing. Oh, so only after add child the whole thing is actually ready. So does it show up anywhere? The sword shows up here in a corner. We can see a little bit. So what happens if I'm gonna change the position here? So we're gonna do sword dot position dot x is, let's say, 200. Y is 200 as well. Okay, I know I could have done a single line, but whatever. Okay, so I was able to change the position of it to be something else before I did something here. Ah. But only after that position, only then I added it. So it inherited it. But that means that probably I can't do something like get child or something. Can I do here, for example, sword dot get child, child 2. And I want to expect end of statement after expression found identifier instead. Oh, var. Cannot pass value of type string as integer. Oh, get node. Yeah, child 2. That's it. Okay, I see. So, can I do something with it? Child 2 position dot x is 200. Play. Invalid access to property or key position on a base object of type null instance. Okay, so the child didn't exist yet. I could move it. Alright, let's just prove it. If I'm gonna take this code and put it after I added the child, after I actually placed it inside the node, no, it still doesn't work. So the child 2 is null. Get child number 2, or like 1. Can I do that? Or just, yeah, well, let's start with 1. But there should be 2 of them. Will that fix my problem? No. Oh, yeah, because I need to call it first. Oh, what the hell is get child? Index. Oh, I put it right in there. What is include internal? Is false. Internal children are ignored. Oh, I think I know what's going on. Internal are from the class itself. So I could not include internal and only get stuff that's attached. Huh, interesting. So let's get back here to the here. So we're gonna do 1. And that should fix it. Okay, we just moved this thingy from here to there. But will that work if I haven't added it to any character yet? Okay, that works. Interesting. So it seems like the whole node is just instantiated somewhere out there in the void. It just the whole hierarchy already exists. And whatever connections were predefined in a scene, they work just like it would work on its own, right? Exactly this. It's just we don't call ready until we include it somewhere in the main scene. Only then it's gonna actually execute ready. Interesting. Very good thing to know, to be honest. That explains something how the things work behind the scenes. Cool. All right, so we understand those things. We know that we can get those classes around. I wonder if I can make enums exported like that, or do they need to be a part of a class? They probably need to be a part of a class. So, yeah, doable. We'll see when we learn about enums. But yeah, okay, I can live with that. Williams005. You kind of sound like an ad, to be honest. Alrighty, so what else do we have? Autoloads versus regular nodes. Godot offers a feature to automatically load nodes at the root of your project, allowing you to access them globally. That can fulfill the role of a singleton. Singletons autoload. Singletons as an autoload. Okay, so they call it both a singleton and an autoload. Interesting. So those singletons, look at that. They offer a feature to automatically load nodes. Nodes, not classes, not anything, not just scripts. Nodes at the root of your project. Okay? And you can access them globally because they're special, right? They're called singletons. These auto-loaded nodes are not freed when you change the scene from code with scene tree change scene to file. Okay, so this is basically like, even though you have your main scene, they will live outside of it and it will just not unload. Okay, that's good to know. I can see it as, some kind of sound manager or something that maybe manages music that, when you change the scenes, or maybe something that stores very important parts of the gameplay, maybe even. I don't know, depends on your game, I guess. Alright, in this guide, you will learn when to use the autoload feature and techniques you can use to avoid it. Techniques to avoid it, so as in, don't try to autoload everything. The cutting audio issue, look at that. Other engines can encourage the use of creating manager classes, singletons that organize a lot of functionality into a globally accessible object. Godot offers many ways to avoid global state thanks to the node tree and signals. For example, let's say we are building a platformer and want to collect coins that played a sound effect. There's a node for that, the audio stream player. But if we call the audio stream player while it's already playing a sound, the new sound interrupts the first. Okay, makes sense. A solution to the code is the solution is to code a global auto-loaded sound manager class. It generates a pool of audio stream player nodes that cycle through it. that cycle through as each new request for sound effect comes in. Say we call that class sound. You can use it. Say we call that class sound. You can use it from anywhere in your project by calling sound.play something. This solves the problem in the short term, but causes more problems. Okay, global state. The object is now responsible for all objects data. If the sound class has errors or doesn't have an audio stream player available, all the nodes calling it can break. Then we have global access. Now that any object can call sound play from anywhere, there is no longer an easy way to find the source of a bug. Global resource allocation. With a pool of audio stream player nodes stored from the start, you can either have too few and face bugs, or too many and use more memory than you need. So about global access, the problem is that any code anywhere could pass wrong data to the sound autoload in our example. As a result, the domain to explore to find a bug spans the entire project. When you keep code inside a scene, only 1 or 2 scripts may be involved in audio. Contrast this with each scene keeping as many audio stream player nodes as it needs within itself, and all these problems go away. Each scene manages its own state information. If there is a problem with the data, it will only cause issues in that one scene. Each scene accesses only its own nodes. Now, if there is a bug, it's easy to find which node is at fault. Each scene allocates exactly the amount of resources it needs. Okay, I mean, it makes sense. If you can just hold the players right in there, then why not? All right. Managing shared functionality or data. Another reason to use an autoload can be that you want to reuse the same method or data across many scenes. In the case of functions, you can create a new type of node that provides that feature for an individual scene using the class name keyword in GDScript. When it comes to data, you can either create a new type resource to share the data, store the data in an object to which each node has access, for example, using the owner property to access the scene's root node. Okay, so the owner is the root node. Interesting. For the specific scene. Does it mean it's just a local owner? Even if I initiate that scene. How does it work? If I'm gonna do in Godot, let's say inside my sword, can I just straight up do something like print the owner is plus the owner dot name? Is it gonna be, let's say that I am inside the sword, GD is inside the sword. So it'll be sword. Well, this will be the main scene root. Okay? Just so I have differentiated. So this is gonna be added into this main one. And null instance. Oh no. So owner is not set. Huh. Interesting. Really? Will that be set when I call it here after I already instantiated it? Sword.owner.name? No. Huh. Very interesting. I did not expect this to be a problem. And this simply string an object. There is an object. Ooh. Ah. Really? Can I convert it? Like force convert it to string? The owner is object null. Ah, ha ha ha. So no, the owner is not set. Interesting. So we need to set it manually or something? That kind of sucks. What the heck? weird. Maybe it's not in ready, but that doesn't make sense because everything is supposed to be already ready. Strange. Not sure what to think about it. When you should use an autoload. GDScript supports the creation of static functions using the static func. When combined with class name, this makes it possible to create libraries of helper functions without having to create an instance to call them. The limitation of static functions is that they can't reference member variables, non-static functions, or self. Since Godot 4.1, GDScript also supports static variables using static var. This means you can now share variables across instances of a class without having to create a separate autoload. Wow, this is recent. Holy moly. Still, autoloaded nodes can simplify your code for systems with a wide scope. If the autoload is managing its own information and not invading the data of other objects, then it is a great way to create systems that handle broad scope tasks. For example, a quest or a dialogue system. Note, an autoload is not necessarily a singleton. Nothing prevents you from instantiating copies of an autoloaded node. An autoload is only a tool that makes a node load automatically as a child of the root of your scene tree, regardless of your game's node structure or which scene you run, for example by pressing the F6 key. As a result, you can get the autoloaded node, for example an autoload called sound, by calling getNode root sound. Yeah. So the thing with those autoloads is that the main difference between something that we defined, for example, here as the item, right? We gave it class name item, right? And then we gave it, so it's basically available everywhere automatically. And we even gave it static var and static functions, so we can just call, make on an item, just like here, right? We didn't need to make an instance of item. We just call it here, we have it available, bam. So the difference between something like this and an autoload of a script or whatever is that autoload will basically create an actual node. Therefore, I believe you can create children of it and a bunch of other things, while this doesn't exist in your tree. So that's the difference here, I believe. So if you really wanted to have a sound manager because you actually want to make it smart because of this or that, or you have a need for that, let's say you want to have it, do you want to make it really simple for situations like, picking up a coin, or let's say you have a situation where you want to delete some item and after that play a sound, and you want that functionality to be defined from within that item. You might be like, you know what, there's no point of me adding the audio stream player into that scene because it's not gonna work, because the moment I delete the item, it just disappears, and maybe I don't want to wait for a whole second or two until the sound finishes before you actually delete the node. Maybe for some reason you need to delete it right now because you have some other things that cannot be queried anymore and whatnot. You might have reasons for that. And therefore, you simply want to do something more interesting. Schmelly Orc says, hello, Speedrunner, Blade Runner, what? Yeah, I'm just gonna do tutorials for Godot, because I'm prepping for the GMTK Game Jam that starts the upcoming Friday. And I haven't done anything with Godot at all, ever. And nothing with game dev for a long time. So I'm just trying to learn a few things and figuring out now that okay, I can make static classes and whatever, but how they differ from something like a autoload class and whatnot, you know, specific things to Godot. So yeah, playing with that. And as I usually do with everything else, I just read through the documentation. So what are you doing? Just enjoying stuff at night or in the morning? Jumping around Twitch? Ah, that's a good one. So we just had a lot of reasons to, hey, maybe you want to use this other node or class or something instead of or scenes instead of just nodes. So now we have the opposite. Nodes are cheap to produce, but even they have their limits. A project may have tens of thousands of nodes all doing things. The more complex their behavior, though, the larger the strain each one adds to a project's performance. Godot provides more lightweight objects for creating APIs, which nodes use. Be sure to keep these in mind as options when designing how you wish to build your project's features. Look at that. So maybe you don't need a node for absolutely everything. Objects. The ultimate lightweight object, the original object, must use manual memory management. Ooh, wow, okay. With that said, it isn't too difficult to create one's own custom data structures, even node structures that are also lighter than the node class. Okay. Example, see the tree node. It supports a high level of customization for a table of content with an arbitrary number of rows and columns. The data that it uses to generate its visualization, though, is actually a tree of tree item objects. Okay. Advantages. Simplifying one's API to smaller scoped objects help improve its accessibility and improve iteration time. Rather than working with the entire node library, one creates an abbreviated set of objects from which node can generate and manage the appropriate subnodes. Not sure what they're trying to say, but I guess this is all related to just dealing with objects rather than creating the whole hierarchy of nodes. You can just make hierarchy of objects if there's no need to actually have them inside a scene or something. Yeah. One should be careful when handling them. One can store an object into a variable, but these references can become invalid without warning. For example, if the object's creator decides to delete it out of nowhere. This would trigger an error state when one next accesses it. Okay. Then we've got ref counted. Okay, we've got some experience with that. Only a little more complex than object. They track references to themselves, only deleting loaded memory when no further references to themselves exist. So this basically they are garbage collected. These are useful in the majority of cases where one needs data in a custom class. Example, CD file access object. It functions just like a regular object except that one needs not to delete it themselves. Advantages, same as object. Then we've got resource, only slightly more complex than ref counted. They have the innate ability to serialize and deserialize, as in save or load their object properties to or from Godot resource files. Okay, examples, scripts. A script is just a resource. It's probably just text, what type, and a name. That's it. Packed scene. All right, so basically a list of nodes and their properties. And other types, like each of the audio effect classes. Each of these can be saved and loaded. Therefore, they extend from resource. Okay, advantages. Much has already been said on resources. Advantages over traditional data storage methods. In the context of using resources over nodes, though, their main advantage is inspector compatibility. while nearly as lightweight as object or ref counted, they can still display and export properties in the inspector. This allows them to fulfill a purpose much like subnodes on the usability front, but also improve performance of one plans if one plans to have many such resource nodes in their scenes. Oh, so probably the whole item thing here should have extend resource. Is that gonna break anything? Or what? When I run it, it didn't break anything. Does it mean that in our main node, we have those items here, right? Can I just make them export? We don't have errors. That means we can go here and we have the array items and we can create them. But we will need to create a new item and then, oh, we edit them this way, like name and type. Okay. And local to scene. If true, the resource is duplicated. If true, the resource is duplicated for each instance of all scenes using it. At runtime, the resource can be modified in one scene without effect. Oh, okay. So by default, I could have the same resource, you know, it's saved somewhere to disk or whatever, or when I created multiple instances of the same thing, it won't create copies of those items. It will just share the references to them. So no extra memory usage. But if I want to, I can make that this specific one, I know, number 3 for some reason, is unique and it can be modified, because if it will be modified during runtime without this checked on, it would change for all of the things. This is fascinating. But okay, at least we know that we can make things configurable this way, rearrangeable and whatnot. This is great. Yeah, exactly. Hello, Iconic Moronic, by the way. It's good to hear you. It's good to see you again. Exactly. So we can have the same resource on the player and in the HUD, for example. So the stats are shared between 100%. Awesome. And I believe that the way they're referenced is just by a reference. So it's just probably an integer behind the scenes. Hopefully. Because by the time they're loaded by the engine, it should be just a pointer. And therefore, you know, we're not holding a lot of data. So as a example of something that I can imagine as a nice usage for that, for those who are familiar with modding, or maybe with how games like Factorio, Minecraft, or what else would there be? RimWorld, many other moddable games, or just, you know, most of the games where you have some kind of inventory, you usually have a list of described items, the possible items that one can have. Let's say a bunch of weapons and other things that each thing has, you know, like 30 different stats, descriptions, whatever, damage versus plate armor, damage versus, you know, whatever, piercing damage, that kind of damage, weight and whatnot. Bunch of settings. Depending on how complex the game is, you can have a lot of settings. And, you know, you can find many instances of the same item. They don't really vary much between each other. And therefore, when you equip that item, when a player equips that item, you don't copy that description. You have a separate thing that you have, like a separate structure that holds all the stats data, and separate thing which is the instance of the item. Maybe something like, okay, which ID it is, which defines the stats, and maybe how many uses there are left, because normally it starts with, you know, let's say 300 hits. And you need to keep track when the sword, I don't know, is sharpening or breaks or something. And this way you can just link the resource and hopefully it's referenced just as an ID behind the scenes, just a pointer, which would make the most sense. And therefore, you could store that data kind of locally nearby without adding a lot of overhead. If that's the case, it will be super, 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 super nice. Yeah. Okay, so let's finish this little article. And I'll be... Oh, we just finished the article. So I guess I'll be skedaddling for now, because I need to get up in the morning and work, unfortunately. Or fortunately, it's good to have work. Yeah, so I'll schedule a stream for tomorrow. Tomorrow we'll have a longer stream. It will start at 9 p.m. of my time, which is Eastern time, and probably till 1 or something. So we'll have a few more hours. And we will probably try to recreate some parts of the platformer toolkit from GMTK. I think this will be a good way to learn a little bit about how to implement platformers, because there's a high chance that the game that I'll be making for the game jam will involve platformer stuff, and this way you can probably learn a bit more about things like the character body or whatever it is, and things of that sort. So yeah, this will be fun to work with, to dissect that. I don't know if it shows code or not. We'll get to know that. Okay, so that'll be planned for tomorrow. And on that note, we'll finish. So I'll say my goodbyes then. Again, thank you everyone for watching. Thank you for participating, for sharing your knowledge. And I hope whatever my blabbing was useful to somebody. If not, then, oh well, I learned something. So if you like the content, consider liking and subscribing on YouTube. Consider following on Twitch. And if you want, you can also join my Discord. It's on in the YouTube description, or I'll add it in a second to the bio or description on Twitch, whatever you call it there. And I'll see you on Monday, hopefully. All right? See you.